team. Welcome back. Can we start now?
हॅलो
हा
तुम
चालू करू शकतो का?
पण हे जगन ते आलेत का अजून?
हा जगन, are you there? Can we start?
मी तुम्ही मागाशी जे सांगितलं ते सगळं मी ऐकलं
Good.
आणि मी जे म्हणजे आता जे तुम्ही म्हणालात की स्क्वेअर बनवायचा हवेमध्ये किंवा सर्कल बनवायचा किंवा 8 बनवायचा हे सगळं केलंय, पण ते करताना ना म्हणजे तो असा कसा म्हणजे ड्रोन आपोआप म्हणण्यापेक्षा कसं काय करतो मॅनेज की बाबा
आपण ते कसं असतं ना, ड्रायव्हिंग करताना आपण ज्यावेळी आपल्याला माहित नसतं कसं आपण ड्राईव्ह करतो, पण आपण काय करतो आपल्या माइंडचं इंट्युइशन वापरून ड्राईव्ह करत असतो, राईट?
बरोबर.
पण ऍक्च्युली काय होतंय त्याच्या मागचं लॉजिक काय आहे ते माहित नसतं आपल्याला. तर ट्रेनिंग मधनं आपल्याला ते समजतं की काय केल्याने काय होतंय आणि कशामुळे होतंय. सो दॅट इज व्हॉट यू लर्न थ्रू द सेशन्स.
ते ऐकून जरा खूप छान वाटलं, म्हणजे अरे हा मी हे करत होतो ते मी असं करत होतो. अच्छा, मला आता म्हणजे त्याचं सायंटिफिक कारण कळली.
हा, परफेक्ट.
आणि ते तुम्ही सांगत होतात की आता मी नावं विसरलो परत. काय म्हणतात ते, आपण लेफ्ट राईट घेतो किंवा हा
त्याला ते म्हणायचं, ते पण लोकांना मराठीला पण लक्षात नसतं की माहिती नसतं की ह्याला काय म्हणतात. ही ऍक्टिव्हिटी करतोय ती काय आहे, म्हणजे रॉ आहे, यॉ आहे की रोल आहे, पिच आहे.
कारण की ते करता येतंय मला, पण त्यांची नावं म्हणजे आता पुस्तकी भाषा माहिती नाही.
बरोबर, म्हणजे इट इज लाईक प्लेइंग क्रिकेट, पण हा शॉट आहे त्याला ऑफ साइड शॉट म्हणतात किंवा ग्लान्स म्हणतात, हुक शॉट म्हणतात, ते माहिती नाही. फक्त खेळायला येतं असं प्रकारचं.
खेळायला येत. हा, चालेल चालू करूयात आपण.
Okay, Jagan, we can start. So we were just discussing that what Pranay was trying to tell is that we play the cricket, right? So when we play a cricket, we don't know what shot we are playing. We just play with the flow. Similarly, he was saying he had flown the drone and done all those exercises, but he doesn't know what it is to be called. When you say raw, right, raw, I mean, as we flow, as we know how to do it, we know how to do it, but we don't know what it has been called as per the technical or as per the book or as per the theory.
Technical terms.
Yeah, technical.
आणि माझा कॅमेरा चालू नाही याचा अर्थ असं नाही की मी ऐकत नाही, मी सगळंच ऐकतोय, फक्त मी म्यूट आणि कॅमेरा ऑफ आहे.
Right. Good. Okay, so let's come to the third session. We are already 1 hour lagging behind. So So we'll see how we can cover the things if possible, or else we may little bit extend here and there. Okay. So the third session is ATC procedures and radio telephony. Okay, this is uh, currently the ATC or the radio telephony topics. Uh, Currently, it is called RTR. Okay, RTR, radio telephony, as restricted. Okay, and this is driven not by DGCA, but this is driven by wireless and planning coordination team. Okay, now there is already a proposal which is going to be there, and this RTR will be coming under the DGCA. Okay, uh, I think maybe down the line, 3 months or 6 months, that segment will get changed, and then RTR will come under DGCA. And as I said earlier, as we intend to move into BBLS environment, this RTR will play a major role, because here, right now, whatever the drones you are flying alone, solo, and within your capacity, you are trying to fly the drone. But in future, as the drone are being flown beyond your visual sight, you will need lot of monitoring behind it. So there would be, since your drone will be broadcasting the signal and all that things, there will be people who will be monitoring your position of your drone and all that things. So you need to continuously communicate with the ATC team, and give this ATC team will tell you about what is happening with your drone and where are your drone and what is your control and what you need to do it and all that thing. So this is whatever I am talking about the future is little bit still not clear how it will happen, what will happen, and all the things. But that is where we are. This is the first step, I would say. Where as of now, the procedures what we are going to follow, or what are the things related to radio telephony or RTR, we are going to learn about is at a very basic stage or initial stage. We may not be as of now applicable to existing drone flying, but probably over the future we may have to study more into it. Okay, there will be a separate RTR license would be required to be taken. You may have to get certified as we upgrade ourselves to BWLS mode, because BWLS definitely RTR will come into the role, and it will have its own examination and all that. Okay, so let's move ahead. So understanding the ATC operations, the communication with the ATC plays an important role as we enter to the manned aircraft space and ecosystem. See, right now what we are talking about ATC operation is like if we want to fly the drone in a probably a red zone or probably in a yellow upper zone, about 200 or above 400 feet. In that scenario, if we are want to fly a drone, we need to take permission from the ATC first. Okay, ATC we need to communicate when we are flying and all that things. We need to. So AT should be informed for any RPAS operation prior to the commissioning of the commencing the operations. It is important to follow the ATC procedures to enter in order to provide avoid interruptions of the manned aircraft. Okay, each aircraft or each RPA operator must be in a two-way communication with ATC. So you need to set up that communication channel. Right now in drone we do not have as such communication with ATC, but when we are doing it, that time we should have those communication channels also set up. We may have to give the command to ATC and tell a lot of information related to our position of the drone, where we are flying, why we are flying, what controls are there. So they will correlate, cross check, and everything, and then only they will give permission to fly the drone in that area. So RPA pilot should be aware of the airspace and the restriction imparted in it while operating the RPA. Okay, so this is very important when if you are flying a drone in airspace or restricted area, you need to follow what are the operating procedures, what are the rules, regulations, or whatever restrictions. They might tell you in this 400, you may have to keep your drone within 500 feet altitude or whatever they tell you. Like when you're flying an airplane, they normally instruct, okay, you bring your airplane to 10,000 feet. Okay, you maintain your the coordinates and all that things. They will keep on telling you, and you have to follow those instructions. And with that instruction, you need to fly the drone. Okay. So what is the radio telephonic basics? The RT means provides where pilot and the ground personnel communicate with each other. I mean, this is from a perspective of the aircraft flying. So it assumes that you are a pilot who is actually flying the aircraft, and there is a personal, ground personnel or ATC person who sits in a tower and he is monitoring your position. So that time you need to keep on communicating with each other. The information and instructions transmitted are very vital importance. Like you must have seen in an aircraft, most of the time whatever the pilot is speaking, it has been recorded into the black box. Okay, a lot of time, whenever there is any air crash or any incident, they will always listen to the what communication has happened between the pilot and the ATC. Okay, so that's very important. Initially, in from a safe and expedition operation of aircraft personnel involved into operations and people on the ground. So whatever communication is happening between ATC and the pilot, that plays a very important role to understand how you are flying and what instructions you are getting and what instructions you are following during your operational activities. Radio telephony techniques. The radio telephony or radio communication must be carried out in the following manner through things. One is RT phonetics. So there is a specialized, I would say, language where you will be speaking whenever you are talking to it. You know, a lot of time what I say, the person other person may not be able to understand. So you know you need to know the alphabets. What like when I say, let's say ABC, a lot of people may not be able to understand what ABC. It may heard like ADC. ABC, ADC can be the same thing, but then sometimes you not understand. So you always say A for Alpha, B for Bravo, C for Charlie. So that way the phonetics you should know. Then RT phraseology, like sometimes you are not able to communicate, properly in a language, or you want to communicate in a way that it is not been understood by others. So normally sometimes people follow Morse code, and then latitude and longitude you need to communicate how. Like let's say when you are landing or you are taking off from particular airstrip. So there is a latitude and longitude is been defined on the runways and all the things. So you need to communicate those latitude and longitudes. A lot of places like bigger airports where you have multiple runways. So which runway you have to land or which runway you have to take off. So there is a latitude and longitude defined out those runways. So you should able to communicate those properly with the ATC, and then you can take it. A lot of time this problem happens during the landing purpose rather than takeoff, because a lot of time people land on a different runway which is being communicated to you. So that mistake should not happen. So you should know what latitude or longitude is being communicated, and you are following when you are landing on those particular latitude or longitude. And the last is the important, what frequency you are actually communicating. You should know particular ATC or particular tower control is operating on what frequency or what spectrum of the frequency they are following up. So that is where your NOTAM and this AIP documents comes into the picture. So you should know, like, if I want to communicate with let's say Surat ATC. So let's see what Surat ATC is having following the frequency for communication. So you need to set those frequency on your receiver or transmitter, and accordingly you will talking to some other ATC and you thought that you are talking to Surat ATC. So you should be setting up the right frequency when you are communicating with the respective ATC team. So there is a frequency spectrum also which we'll see further. Okay, as we're talking about phonetics, so you see from the Morse code, the letter A, for example, letter A. So first, if you see Morse code, there is a dot and there is a dash. Okay, so dot dash. So in telephone, it is aha. So it is alpha. Okay, in a pronunciation perspective, A for alpha, B for Bravo, C for Charlie, D for Delta, E for Echo, F for Foxtrot, G for Golf, and H for Hotel, I for India, J for Juliet, A for Kilo, L for Lima. So like this, all the English 26 alphabets like Z for Zulu, Y for Yankee, X for X-ray, W for Vixie, V for Victor, U for Umbrella, T for Tango. Like this, you should know S for uh, Sierra, and R for Romeo, Q for Quebec, P for Papa, O for Oscar. So these words, whenever you are finding it difficult to explain, like even in our day-to-day communication on mobile, also a lot of time we say, okay, I am from like when I'm talking to someone in international level, somebody talking from Singapore or somebody talking from US or UK. Sometimes we talk about the city. Okay, I am based out of Mumbai or I am based out of Chennai. So they do not understand the name or something. So we should, we make to pronounce them, or we tell them it is C for Chennai, H for hotel, E for eco, N for, something like that we'll say, N for November, and then again A for apple and I for India, like that. So then they will able to call, okay, that's the Chennai, something like that they will say also. That way. So we should communicate. Even numbers are like, in the Morse code, it's very easy, but 1, 2, 3, 4, 4, sometimes we have to split it out, 5, 6, 7, like this. So this is the radio telephony phraseology, I would say, phonetics, as well as, in Morse code, how do you do it. So you need some time to practice this Morse code. As of now, this Morse code or even the phonetics is for general speaking. When we are speaking, it only sometimes we say, okay, I'm going, let's say my altitude is, let's say 5 meters, or 5 feet, I'm going up, or 10 feet, I'm going up. All that things will communicate. Okay. Whereas if you are flying a drone between two locations, let's say you're flying from Surat to Ahmedabad, or Ahmedabad to Surat, or Bombay to Pune, or from, let's say, for example, let's take of Chennai to Madurai, or something like that. So when you're flying between two different cities, you may have to communicate a lot of things, and then there will be a lot of jargon when you're talking in English. So sometimes the person who is next on the phone, because it's a long distance call over the wireless network, you will sometimes find a lose in the communication. So you talk very slowly, you talk or split one by one the words, alphabets, and then accordingly the person will interpret, and then it will be a more clearer communication. The importance when we are talking or when we are speaking in drone, we have to make sure that we are communicating very clearly and we get acknowledgement what he is saying, or what we have communicated, he communicates back to us, so that we are on the same page, or we are on the same line what we are talking. Okay, so these are the characters, alphabets which are being used in regular communication. Okay. So again, here alpha, bravo, Charlie, Delta, whatever I talked to you about. So these are the things what you need to understand and know, if when we are upgrading ourselves in BVLS or RTR exams. Okay, this is Morse code. So there is a way. It's like you don't learn. See, if you want to learn a Morse code, there is a way. You can't start with A as a dot, 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 and dash and all this. So there are some characters. Like if you see A and then N, there and then there is a, like, you will start with first simple characters like E. E is only one dot, whereas if you see T is dash. So you start with first pointer. Like you will first know what is E. E is dot. Then T is dash. Then again you will see two dots. Okay, two dots will be there. Then there will be two dashes. So like this, you should identify which are like I. You will understand I first. So E ke baad you will learn I. Then you will see two dash is N. So that way you start learning. So there is a way. There is a way to learn Morse code also. How to learn the Morse code. Okay. It is not that how we learn the alphabet like A, B, C, D, E, F. It's not. In Morse code, we have to start with one single dot, then one dash, then two dot, two dash, then again three dot, one dash. There is a pattern to learn these things. Then it will become easy. So learning Morse code this way, in a standard way, it's very difficult. You will not able to learn it also, or you will not able, because you need little bit to memorize them also. Actually it is not reading, or it's not actually speaking. It's basically seeing and listening. Okay, seeing and listening. So by when there is a dot and when there is a dash, so dot is like tuck, whereas dash is like little bit longer. So actually dash is nothing but three dots. The time taken by three dots is one dash. That's how the Morse code is been designed, and this is primarily used earlier in World War One and Two for communication, where the other enemy people will not able to intercept, or enemy people will not able to understand what we are communicating to them. Okay, but over the period time, Morse code is been standardized and used by everywhere. So even right now, if we communicate in a Morse code, all other people will also understand. So if they are able to intercept your Morse code transmission, you will also able to make it out there. But again, what you are communicating, how cryptic you are making it, it will make it difficult. You may be communicating, your words may be communicated and unfold by them, or they will understand what is you are communicating, but they will not able to make. So you have to make your communication cryptic also. So that's how people. But more and more things are been available now where they will decrypt whatever you have been communicating using the Morse code. Okay, Morse code is only simple. Like you, can you tell me any example where earlier this Morse code was used?
With this raw diplomatic channels,
Correct, correct. That is the current usage. But in old days, before mobile, before television, where this Morse code or where this was used, because this takes a lot of less signal, less power, and
Submarine?
submarine. Yes, even today. But I'm talking about the olden times, in a day-to-day use, in a day-to-day use, I'm talking. Not from a very special
Mobile
use.
phone.
Phones means even before the mobiles were there, or even the telephones were there. You know the telegraph system.
Okay.
We used to send a wire, right?
Mm-hmm.
Telegram, what we used to call. Not
Physically.
today's Telegram, but the older time Telegram, where you used to you have a limitation of sending the words, because every word was a charge or a cost to you. So you used to use set some very small, come fast, like somebody has expired, so we want to pass on the message to someone important. So we will send a telegram in those days. So those telegrams were using this Morse code language, and so that the person sitting on the other side of the telegram, he will interpret and he will type those words, and then that telegram you used to get it at your house, something, baby born, baby boy born. That's it. Only you will just send a telegram to pass on the good news also sometimes to some important person or somebody like that. Okay. So that's the usage was there initially in a day-to-day communication or in a regular people's life. Telegram was used. Okay. Now, as I was talking about the communication about the latitude and longitude, you know what is the latitude? Latitude is nothing but the horizontal lines on the earth. Like your equator starts with the 0 degree, and then subsequently you have 10, 20, 30, 40, 50, 60, 70, 80, and 90 degree, and on top of the North Pole. Similarly, your vertical lines or vertical longitudes are been derived. So there are like 360 degrees of longitudes you will have. So based on your latitude and longitude, you will pinpoint where actually your drone or your aircraft needs to be landing. Whereas your prime meridian is the line which passes through the Greenwich time, from which the time zone, actually longitude comes into the picture mostly during the time zone period. So you will understand which side of the earth you are located. Okay, whether you are, like we normally say in India, it is IST. So based on the latitude, our IST has been defined. So we have only one time zone for entire country. Whereas some countries like US or even Russia, they have multiple time zones or multiple uh, segments, or because of the multiple longitude lines passing through the country and all. Okay. So what are the frequencies we have? So most of the time, like if you see VLF frequency, where radio navigation happening between the ships, or there is a tower. So there are different frequency. They are very at a, I would say, very higher wavelength. You see 100 kilometers or 10 kilometers wavelength. Their wavelength is very high. Whereas if you see like radio communication, what is happening, AM radio or even aviation radio navigation or shortwave, medium wave radio, or even television. These are very small frequencies. Like you see 1 kilometer, 1,000 meters, 10 meters, or even 1 meter kind of things. But if you see mobile, UHF televisions, mobile phones, GPS, Wi-Fi, 4G, they uses very shorter wavelength of the signal. So UHF, what we call it. Whereas when there is a communication happening between satellite and the radar, most of them radio astronomy, they uses very small, very short frequency kind of this thing. So you will see 1 centimeter, 1 millimeter kind of signal they would send. So there is a fast communication happening between this. Whereas here, if you see, it is 100 kilometers, so the wavelength is very big. So transmission little bit takes longer time, but eventually you will have the signal. Depends upon, because again every transmission is related to power, because you are doing nothing but you are sending a signal and you are implanting a power. So the more what do you say frequency you are sending, higher frequency, like shorter frequency, I would say. Shorter frequency means your waves is very fast. So every beat or every signal, there is a power. It's a power related to frequency. So more frequency you are sending, the more power it will be using. But definitely it will be faster also. The speed will be not that effective, but the amount of time the data is transmitted over the satellite communications, or even in Wi-Fi or mobile and all things, the transmission data is very fast, huge amount of data. Whereas if you see our short wave or television or even radio, there your frequency is very low. And compared to that, if you see, there is a communication happening between the ships, in the naval navigation of thing, where you do not have much to communicate. You are just simply like ships. What they do communicate? They communicate the position of their ship in the sea or something like that. And until unless there is some disaster or something where they need to communicate, so they will use different channels that point in time to communicate. But in a normal day-to-day communication, they probably will use VLF or LF. Okay, but now right now most of the locations and all things, they are all using UHF, SFF, or EHF kind of frequency, because everything is now moving in a very fast direction, and they want the speed of the communication to be fast. So though this is the RT frequency spectrum defined, but as of now, this really in real world it doesn't make sense. Like even from the ship right now, the people are communicating using mobiles, because you have set up the communication channels in such a way that it is across the globe. You can communicate to anybody, anywhere, right? So right now, even you must have heard the internet is available. Guys, internet is available through a separate series of satellite. Like Elon Musk is already running the Starlink. Similarly, there are a lot of other bodies who are running internet over the satellite communication. So you do not have really using a different channels for communication. Only thing is that you're using a particular frequency for particular mode of communication, or particular device to device. You can set a particular frequency to communicate with each other, right? Any questions over here?
No, we are good.
No, sir.
Okay. Okay. So when we are talking into our ATC in unmanned, okay. So normally what will when we are communicating to ATC, let's say assume that we want to fly a drone in a yellow zone. So how we'll communicate to this is one of the important slide. This normally when we upgrade ourselves to or master trainer or trainer, this normally questions is asked on the communication part from the DGCA examiner, how you will communicate about yourself to ATC when you are flying a drone in a yellow zone. Okay, so what you will communicate? So you will communicate about RPAS, the number, UIN number. So he knows what UIN or what drone we are trying to fly, and then we'll give him the latitude and longitude, and then we'll give the radius, like if we are going to fly in 5 kilometer range, or 10 kilometer range, or 2 kilometer range, whatever it is, and that what would be the altitude base to ceiling. Like for example, for my base, like in ATC normally above 400 is the base for the green zone, and if I'm going to fly with, let's say, 400 to 600, so I would say base is 400 feet, and my ceiling would be around 600 feet, something like that. And what time and what end time I would prefer. Like probably I would be flying Indian Standard Time, 10 p.m. or 10 a.m., whatever it is. I'm normally VLOS is it is in the daytime, so I'll say 10 a.m. I'm going to fly, and my end time I'm going to fly maybe by 12 or maybe 11, whatever, depending upon the endurance capacity of my drone. Okay, so remote pilot should prefix the RPA call signs with the word unmanned. So we have to, whenever we are talking about drone, we should always talk about it is a unmanned. Okay, because ATC is sitting in some remote location. He doesn't know what you are flying or what you are. For him, it is just a dot on his screen. Okay, so we need to tell him that we are flying a unmanned. Unmanned means a drone. Okay, wherever we have to have a voice communication with the ATC. Operator needs to inform ATC with the exact latitude and longitude. Matlab, if you are flying, let's say I'm flying in Bombay, so I'll tell I'm flying at 19-degree latitude or 72-degree north of my longitude. So all that communication has. Then again, I have to tell the radius, like maybe 2 kilometers, 5 kilometers, whatever radius I'm going to fly, what altitude I'm going to fly from base to ceiling, and all that. And then if possibly if there phraseology we need required to use, if you're talking about, let's say I am right now in Mumbai, some location, my location name is Bhinder. The person who is sitting in ATC, he may not well versed with the location, he may not be knowing. So for him to understand, I may say my short form or short form for my location is BHY, But BHY he will not able to. So I'll say Bravo, Hotel, Yankee, BHY. That's where I have to communicate. And then ATC frequency are to be monitored on a listen mode only, and communication is to be maintained via landline. So lot of time there is a two different channels are used for communication. One is we are just at a receiving end. That means we are only listening mode. So they are passing out, but when we are talking to them, we may use a landline communication to ATC. Lot of time we use phones or something like that. We are when you are communicating to them. Okay, especially the landline. Then radio communication on airband frequency is only allowed for the operator who is certified to operate. So this is what I was talking. He is certified to operate wireless. So when we are using a ATC device, the wireless or some device where to communicate to ATC, that is only applicable if you have cleared your RTR exam. Okay, so wireless RT equipment, a valid RTR protocol issued by wireless planning and communication illusion or DGCA respectively. Why I have written DGCA respectively? Because DGC is going to take over this RTR part now in short term. So it will not no longer, it will be under WPC. Okay, so that's why I've written both names over here. And a standard phraseology is used throughout the globe with minor difference with respect to the different regions. Sometimes, like in German little bit language is little bit different. So accordingly, we need to communicate. Or Russian, they not understand A for alpha, B for Bravo. So sometimes there is a little bit difference also. As of now, for us, we don't have to worry about it. From an English language perspective, there won't be any change or any difference into it. It's only if there is a little bit change in the language, or sometimes when we are communicating the English person communicating to France people or French people or German people or Russian people. Depend. Like sometimes their language or their way of understanding the English is little bit different. So accordingly, there is little bit changes into that. Then only it has to know. Whereas when we are communicating in English to English, we don't need to have any change or anything. It is a very standard phraseology what we use. A for alpha, B for Bravo, C for Charlie. Like that we have to use it. Most important when you are communicating with ATC, the first important say you have to say is unmanned, and then UIN number, then latitude, longitude, and the altitude and the location. That's it. And then start time, end time. These are the first most important things you need. And people might ask you, the DGC examiner might ask you how you will communicate and what you will communicate to ATC. So this is what you need to tell to the examiner that this is what I'm going to tell that I'm unmanned aircraft flying an unmanned aircraft with so and so your number. You might have heard when the pilots are communicating to ATC, they always talk about what is their sign of their aeroplane. Like every aeroplane in India, you must have seen starting with V, Victor, Tango, and then some number would be there. So they will always communicate that I am talking from this plane. So that plane number. Similarly, when we are talking about the drone, we should talk about the drone UIN number, that 12-digit number, alphanumeric number, whatever is there. My registered UIN number is there of the drone. That I need to communicate first. So they always cross, okay, for this particular drone, this latitude, this longitude, this altitude from base to ceiling, and then what is the start time and end time. They once they say, and then they will check it in backend whether the necessary approvals are there, or they will ask you might be to provide those approval documents and all the things. So even before you, this is all communication before you actually commence your flying. So you may call them, let's say at 9 o'clock in the morning, and communicate all these things to you. And then you will say what is your start time. So they will say okay 10 a.m. Your start time you might have said I want to fly at 10 a.m. or 11 a.m. So accordingly, okay, you will give them some time to validate and everything, and then probably you will call back and check whether I am cleared to take off or not. They will say, okay, you are cleared to take off at 11. So they will communicate, and then you will at 11 o'clock again you have to have a set up a communication with them, and then you said I am going for takeoff. You take off. So when they take off, they will keep on monitoring. If there is something, they will communicate back to you. If not, you continue your operation. You finish your operation. When you finish your operation, you again communicate that I am completed so and so UIN number. I have completed my operations and going for landing. So that's how you communicate as a standard radio terminal. Okay.
Yes, sir.
Now, as of now, this is not incorporated into the Digital Sky platform. We have seen the Digital Sky platform. If you see here, we saw this space, right? So as of now, there is no what we say settings where we can define the path, okay, of our flight or anything like that as of now. But in future, we will able. Let's say, for example, if I'm flying the drone from one location, let's say I want to fly from Mumbai to Surat kind of thing location, let's say, or maybe Daman or something. So I will have to define the path from what location it is going to take, what location it is going to land, and all the things. So during that point in time, the flight planning on a digital sky platform is necessary. All the landing zones, emergency landing zones should be pre-planned before the takeoff. Let's say in between my battery may be behaving very absurd or some problem. And in between, I need to land somewhere my drone in between. Let's say there might be, let's say Danu is there. So there might be a place, sorry, Daman, I am going to land. But in between, I find that my drone is not drawing. So there might be some emergency ports. Those are called vertiports. Okay. So if there is a vertiport defined, I may have to tell that okay, I have to do an emergency landing of my drone at the vertiport because probably my uh, battery is showing 60% power loss or something like that. So immediately, whatever the nearby vertiport is there, I may have to land my drone over there. So there might be some technician would be available. He will check once the drone is landed, and he will check and let us know what is the issue, whether the battery is power or battery needs a recharge or something like that. So he may charge the battery over that location, and once the battery is 100%, then I may resume my operations to Daman, or I may call back my drone back to the home. Okay, so whatever based on whatever decision, the technician would may provide me the maybe my battery is not in a good shape and it may not be able to go further because again going further and in between again some same problem or something happened. I may not have a vertiport. I may not able to fly up to the Daman, and then I may not have vertiport. Maybe my drone might crash in the sea or maybe on some land or some place. So I do not want to take risks. So I might feel that okay, let me get the drone back over here. So if it is possible, I will fly the drone back to the home location. If it is not in that flying condition, I may abort my mission over there and I'll get the physical drone through the land or something that point in time. That's how we will plan the missions or flight plans. Okay, so all landing zones, emergency landing zones should be pre-planned before takeoff. FIC and ADC should be taken. All flight routes should be predefined. You can't deviate from your plan. So whatever the plan is you are making, when you are making a flight plan procedure, you should follow the route. You should follow. You should define your flight. You can't say I am going from Mumbai to Daman and I cannot go like this on my own way or my way. If I have defined a latitude, there might be some points where I have to define the checkpoints. You must have seen when aircraft are flying, they do not fly here and there and left and right. A lot of places, I don't know whether you have seen it or not, a lot of places you will see it's an empty ground and there are a lot of towers are there with the cables attached to a signal tower. They are transmitters and receivers. So every time the aircraft fly from that region, that particular location captures the signal. It knows which aircraft is flying at what location, where it is, or where it is past, not past. That's how the ATC knows the flight path of the plane. Similarly, in a drone also in future, when all the vertiports are being set up, okay, vertiport is documentation has just released last year. I think it was released in September. So just recently, the vertiport documentation has been released. Still, there is no single vertiport is been set up in India as of now. Okay, it will be in process. This will come into the picture only when we are doing intercity. We are traveling or we are sending drones from one location to another location across the cities. Then only this vertiport will be coming. Government has already made mandatory that on all the national highways or express highways, we will have some locations, maybe down the line, maybe 10 kilometers, there will be a one vertiport set up so that when your drones are flying, you have a place where you can safely land your drones at those locations. Okay. So collision of RPA can occur due to following reason: flying away or visual loss of RPA, GPS failure, so loss of orientation, motor failure, or due to human error. So when we are flying these drones, and a lot of times this kind of situation could occur. Now, how do you avoid collisions? So first of all, these are the criteria where your collision or some failure could occur. So other reasons may include like conflicting traffic, terrain or obstacle, or hazardous material. Sometimes all of a sudden your climate gets changed. All of a sudden within half an hour, the entire visibility you may lose visibility, or there might be some ground operation or other airborne hazards. In such scenarios, can be avoided with the help of a sensors installed on RPA or by the operator's intervention. So a lot of time there are some centers like ADSB is installed. We will come to know there are like for example in agriculture drones there are already 3 radars are there on those drones. If radars are not there, it cannot avoid the collision. It will not know there is a tree. It will not know there is a difference in the terrain, height of the terrain. Even when if there is uneven terrain, let's say in our flying zone initially, we have a terrain. There was a this difference between the land by 3 meters. Okay, so that was a challenge what we occurred when DGCA came for inspection, and they said that your flying zone where you are making a flying zone is having a terrain difference of 3 meters. You cannot have a terrain difference in a flying zone uh, less than 500 zero point 0.5 meters. So we have to, after they have given these observations and objections, we have to get our land completely leveled up. So we lost the 10, 12 days to get the things. We got all the contractor and made the land all equal at the place. That we have to actually dig where there is a high part and bring all that sand on the lower part so that the land is very, very equal uh, from any place of the corner in that particular flying zone. So why? Because when we were doing the drone testing, at the one point it went like this. They asked us to set up 10 meters, okay, 10-meter altitude. So we flew the drone it 1 to 10 meter, and then they asked us to roll right. So we went roll right, roll right. There was a difference of 3 meters. So the drone started climbing. So it has to compensate because from the base with respect to the earlier part, it was exactly at 10 meters. But when it went to the higher terrain, the difference of 3 meter came. So the drone will adjust automatically. So there is a radar into it. Okay, if radar was not there, would have gone straight. But the difference it would have shown on my remote control, it would be 7 meters rather on 10 meters. It would have not compensated on its own the difference in the terrain. So you need to have those sensors so that you avoid. Let's assume if there was a hill, it would have straight away bumped if I didn't have a radar into it, right? So just to avoid those kind of collision or those kind of challenges, there are different sensors are being fitted on the drones. Like you might have seen in DJA. DJA has almost I think 6 or 7 sensors, obstacle sensors in Phantom Pro. I have seen there are 6 to 7 sensors across 360 degree. It has an obstacle sensor so that it's very difficult to crash. I mean, the DJI drone on its own to be crashed with any obstacle. It will correct. There will be, I think, some ceiling is there of 2 meters from the obstacles. I don't know whether when you are flying a drone, whether your remote control shows that you have those settings to set. Like you can set also how far your drone has to be from obstacle whenever it is flying. Like you can set 2 meters, 3 meters, 5 meters, depending upon how safe you want it to be from the obstacles. Okay. Now let's see about airspace, different types of airspace, structures and restrictions. So primarily there are 2 categories of airspace. One is the regulatory and another is non-regulatory. Within these 2 categories, regulatory and non-regulatory, there are 4 types. One is controlled, uncontrolled, spatial use, and other space use. Now, why we have different types of airspace things? Like one is regulatory means which is regulatory, which is monitored by the ATC. But non-regulatory means there is a space which is not been monitored by anybody, or there is no regulations on it. Like for example, on the sea part, from one particular zone to another zone you are flying. In between, there is some zone is called like blind spot or blind flying, where you are flying on its your own. Okay, there is no monitoring of that particular region. That's the non-regulatory kind of thing. Then again, in this regulatory and non-regulatory, there is something called controlled and uncontrolled. Controlled means like above yellow zone is your controlled space, whereas below yellow zone, where you have a green zone, let's say you are flying in a green zone within 400 meters. That is uncontrolled. That is not monitored, or that is not been controlled by anybody. So that's why your drones are allowed to be flying in a green zone under 400 ceiling, because that is uncontrolled space. Then there are some specific use cases of the space also, airspace, like probably aerodrome area or some important locations or where they are special use or special thing. And then there are something which is not categorized or not defined anything else. Like those are like other airspace kind of. So these categories or types of airspace are dedicated by complexity or density of aircraft movements. Like the more, like you have seen Mumbai airport, how it has been defined, so much red zone, so much location, nature of operation within conducted within the airspace, level of safety required, and national and public interest. So that's why you see even you have airport at Nasik also, but see the complexity around it. But whereas if you see Mumbai, how much it is so complex and how much it is extended compared to the Nasik, or even if you see this Shirdi location, or even if you see Surat, compared to these cities, see how complex is the zone defined at the Mumbai location, right? Or even in Pune location. See here, okay, Pune is completely now put it into the red zone. I don't know why they have put it, but that's how they have put it. Even Mumbai location outskirt, I mean within the sea, because this location you will see lot of oil rigs are there. Okay, and wherever there are oil rigs or some kind of a refinery. Even see in Kerala location there is a refinery and all the things are there. So you normally see they have been put under the high zone or a high alert zone or a red zone kind of things. So controlled airspace. So this is again defined with respect to the ICAO standards, class A, class B, class C, class D, E, and class E. So we'll see what are these. Beyond E, there is other classes also, but those are very least important. Okay, so this is the picture. So you will see class A. Where is class A? Class A is above 18,000 from the mean sea level. Okay, whereas class B is there. So again, you have a limitation over here. How far you are flying? Like class C is there, then class D is there. But this is more from a aircraft flying. Right now, from drone perspective, you don't have to worry about any of these classes. Nobody is going to ask you about what are the airspace classification. This is more from when you are going to fly into the yellow zone or in these zones. Especially when you are going for a license for aircraft. When you are going for a license for aircraft, remotely piloted aircraft system, that aircraft or aeroplane where you are going to fly remotely or autonomously, that time you will have to understand this thing. For that license, there is a separate module which talks only for one half, 1.5 hour only on these different classes. Okay, how and what range, like this is 18,000 above the mean sea level, this is 14,500 above the mean sea level, like this. Whereas you see class C, class D is there, non-towered airport with no instrument approach. Okay, so like this there are different airspace classifications are there. As of now, nothing to worry about this. Nobody is going to ask about this points over here. This is only from a perspective that there is something airspace classification is available for aircraft flying in the region here. So when we are flying in class A, instrumental flying is required. There is no speed limit. Then RT contact, when a two-way communication has to be there. It has to be, see all these classes, A, B, C, D, E, F, E, sorry. All are these, you need to have the communication with ATC. So as of now, we are not going to fly our drone in any of these classes, because if you have to fly a drone in these classes, you need to have to communicate with ATC service. You need to be have a RTR certified person to communicate, and then you need to have approvals to fly into these restriction spaces. So all these are, see, you see, this is completely a red zone. Class C is completely a red zone. You cannot fly a drone here in these red zones. Forget about the ground, but this level we cannot reach out in the existing drones because we do not have. See, you when you see those type certified drones, they have a cap limited, like they can flown up to only 400 because they have defined or they have configured a drone such a way that it will not go above 400. Okay, it will simply do RTR. It will simply go to the launch section. Okay, again this like how classes of airspace, like what rule you have to follow, whether you have to visual flying rules you have to use or instrumental flying rules you have to apply. Okay, in class B you can use both IFR, VFR, how what communication, whether you have to use ATC, non-ATC kind of thing it will talk about. Okay, clear whether you will receive the clearance or not and all that things. Separations, So as of now, don't worry about this much. This is not for a drone flying required. Only this part is being introduced into the syllabus because DGCA wanted that people should start knowing, start learning more about it because in future uh, this would be coming into the usage as you upgrade yourself for higher licenses and all. Okay. What is the special use of airspace? Or special use. Special use of airspace are operations designated for which certain activities to be conferred where limitations may be imposed on aircraft operations that are not part of those activities. So what are these special? Some prohibited areas, restricted areas, warning areas, military operations. Like you might have a military base, like for example, Jaisalmer, okay, or some place on the Pakistan border. There are a lot of places where you have military operations where you can't fly. These are special use airspaces where you can't just simply take, though they may be extremely away from the locations of the red zones and all the things, but they are nearer to the boundary or thing. That's why if you see boundary, see it is all red. Boundary of Earth, boundary of our country. See, everywhere red, wherever it is, that is a boundary. Okay, so you cannot fly drone within that 25-kilometer range of the boundary. Okay, see Jaisalmer. That's why I talk about Jaisalmer. Anyway, Jaisalmer as a city, it is a red zone because it's very close to the Pakistan border. But here also, this area also you can't fly the drone because that's a special area designated by the government of India or military purposes operations are there. Then alert areas. Sometimes there are some alert areas or controlled firing areas. A lot of places there are where they have those guns and all that thing. So even somewhere some testing is also like in near the Nasik also there is one area where they test the guns and all that thing. So that places you cannot fly the drones over there. Then what are the other space areas like local airport advisories, military training routes, temporary flight restrictions, or some places like parachute jump aircraft operations are going. PFR routes, terminal radar services, national security areas, air defenses area, flight restricted zones. Like example in US, it is vicinity of Capitol or White House. Similarly for us, like it could be Parliament, it could be uh, government official buildings. A lot of places are like India Gate is there, Gateway of India is there. Some temples, even some temples, they have been flight restricted. You can't fly drones near those temples and all that. So those have been defined under restricted zones and all that. Again, a lot of wildlife areas, national parks. You can't operate drones in those areas. You have to take permission for them. Or even the ocean part, near the like because a lot of time the platforms are there, rigs are there, so those places also you can't operate these things. And again, a lot of places, especially the meteorological locations are there, where the weather is being monitored. So they fly ether drones. So those locations also you can't fly drones because you may damage or get collision with those drones. So those balloons, especially for observation and weather recording. So they have a cable going to that balloon and then measuring a lot of atmospheric inputs. So those locations you cannot fly the drones. Those are all nothing but they are restricted or other area space, airspace areas. Okay. Now, when we are flying a drone, okay, so this is applicable to the drone as well as the spacecraft also. What is the distance? Okay, so if you see at the sea level, okay, at the sea level, what would be your pressure? So it is 10. I mean, it is 1013.2 hectopascal is the pressure at this point in time. At this point, this dotted line, what you see. So with respect to that, this is the standard pressure of the at this particular level. So if you see from this sea level, what height does the drone is flying? That is called QNE. Then there is something, because everywhere the sea level is almost similar, but there is some places where you will have little bit higher or up and down. So that's again, that is a different space, different height, what we call it. Normally, most important is QNE and QFE. QNE is from the mean sea level, okay, or the sea level, I would say. Whereas QFE is because based on the land. If, for example, if I'm flying near the Mumbai, it is very close to the sea level. So my QNE and QFE, the difference would not be much. But let's assume I am flying the drone in Delhi, which is very far from the sea level and very high altitude. So there QFE would be different compared to QNE, because from there the QNE sea is very very far from Delhi location. Or take an example of Chennai. For example, near the Chennai city would be QNE and QFE will be less difference. But if you go to, let's say, a location, let's say Tirupati kind of location, that is at very high altitude. So your QFE would be very small compared to QNE over there. QNE is with respect to the sea level, whereas QFE is with respect to the earth surface or the land mass. So there is a difference between QNE and QFE over here. Okay, so here, height above the ground, QFE. Sorry, height above the ground, QFE. Okay, a local altimeter setting equivalent to the barometric pressure. So all the heights are measured. There is a barometric sensor inside the drone. Similarly, there is a barometric device set into the aircraft. In a drone, there is a small sensor, barometric sensor is there, which measures the altitude based on the pressure. Okay, the pressure measured at the airport altimeter, usually signifying the approach end of the runway. So at the runway point where the the aircraft is going to start, or end of the airport runway, that point location we measure the zero as a zero at the ground level, and from there you will measure the height. So that is what is going to give you the QFE. Whereas QNH, a local altimeter is ultimate to barometric pressure measured altimeter collected to the sea level pressure. All the airport altimeter term or are set to QNH, indicates the airport elevation. That means how height from the sea level, how height the particular location is there, and from there you are measuring QFE. Okay, so your altimeter at QFE at the ground is zero set from the QNH. Okay, whereas standard ultimate QNE, it's a pressure, standard pressure at 1013 hectopascal. That will be procedure to standard altitude provides the base of the flight level. That if you see this picture, okay, this is your base, okay, because this is a standard pressure across the globe. Okay, but your difference will come where? Because of the elevation, because of your land. See, for example, you're flying over the Mumbai or Pune region, the QFE would be different when you are flying your aircraft, when you're flying, let's say you're flying over Tirupati. Tirupati is at very high level. It's almost like 1,200, ground is at 1,200 meters above the sea level. So that 1,000 meter, the difference will be always there when you're flying your aircraft from sea level from Chennai location to Tirupati also. So that difference, the altitude will, altimeter will vary that difference. So you have to understand that you are above this ground level, whereas when you are nearer to the sea level, your ground level is very almost zero to the sea level. So that difference would be there. So you need to always adjust your altimeter settings to what is the actual setting you have. Okay, see here. So this is elevation. You can see the elevation over here. The standard QNH is at base of the mean sea level, whereas there is at a standard pressure QNN. So your flight level will be always measured from QNE with respect to the height of the location. Like if you see from this location, QFE is with respect to the land. From a standard perspective, this is what is you need to take care. That is what we say the flight level is at this position. So there would be different altimeters would be there, especially in aircraft. Okay, you can't rely only on one altimeter. You will see there would be three altimeters in the aircraft. One is for each pilot, and then one is cross, what is called as a comparison kind of thing. So there will be always three altimeters in any aircraft. Any big aircraft, you will see there will be always three altimeters. So let's say, for example, if you just keep two, okay, if you keep two, what will happen? We'll not know which is right and which is wrong. But if you have three, chances of two going wrong is very less. Okay, so let's say one might be showing 10 meters, whereas other will show 20 meters, and third one will also show 20 meters. So you will say that 20 meter is more accurate because two altimeters cannot at the same time, right? And they cannot show the same wrong information. So you will always, that's why you always have a three altimeters in a aircraft. Whereas in drone, you only have one barometric sensor. Maximum higher capacity drones, you might install two barometers. So just to get a accurate what do we call information about the altitude. Similarly, like if you see in DJI or even there was one drone I showed you about Asteria. Okay, they were having two GPS model. One single GPS model may show you the wrong information, but when you have two GPS model, there will be always correlation among both each other, and then you might have a more accurate and more precise positioning of your location of your drone. So the more you add the sensors, the more redundancy or more accuracy you will have within the drones or devices, aircraft. Yeah.
Mangesh,
Yeah, go ahead.
so here just summarizing my understanding. So the QFE is something the height of the aircraft
On the land.
the land. Yes, yeah. And the QNE and QNH. QNH is I can take a sea level, right?
Sea level, mean sea level.
I mean, it will be different. It will be same for everyone.
Same for everyone.
Okay. And QNE
Ideally,
is an
QNE and QNH would be same for everyone because, see, based on QNH is not going to change anywhere across the globe, right? But what happens, let's say, because of the tides, your sea level is changing every time. Some place you will have a high tide, some place you will have a low tide, right? Because if you see the when there is a tide, where there is a high tide, opposite side there will be low tide. So what will happen? Your sea level is changing, right? You will have two different sea levels, correct? Now you have to average it. How you will average it? By using the standard pressure. That is 10113.25 hectopascal. So that QNE will give you the accurate flight level. You are averaging your low tide and high tide location. So that is so. If you are following QNE, you have to follow QA. If you are following on a land, you are following QFE, you have to follow QF. That way. So because what happens? Let's say for example you are taking off from Bangalore. Most of the time you must have seen when they're flying, let's say Bangalore to Delhi. You're not flying over the land. Most of the time they will fly from Bangalore, they will go, they will come on the sea part, and then they will fly, and then whenever they are nearer, they will go to. But suppose let's say they want to fly to Chennai, Mumbai to Chennai. In Mumbai to Chennai, there is no sea. Maximum they will go on the land only. So they will always follow QFE. Depending upon what location you are flying your drone, according to that you have to adjust your altitude or adjust your flight levels. So when you are doing, let's say for example, I take off from Mumbai, I may start with QFE. When you are changing your altitude settings, okay, so you will always say changing the altitude level from QFE to QNE. That's how you give update to ATC because your readings of your altitude with respect to QFE will be different, with respect to QNE will be different. So when you are communicating to ATC about your height, you should always communicate with respect to what height you are measuring. So when you are flying on the sea, you will always reference as QNE because you are averaging it out, average. Okay, but when you are flying on the land, so you will always with that elevation part. So QFE you will communicate. As simple as that. I mean, this should simplify your doubt.
okay. Okay.
QNH is not in use.
Okay. Okay. That is only
That is only just for
for
a
a
reference.
calculation purpose.
Yeah, just for reference.
Okay.
Okay. So with this, we complete our DPC procedures session. If you have any doubt, I mean, here this is more from how you communicated. Most important is your latitude, longitude, your height, altitude, and your what is that? How much where QNE or QFE you are there. So there will be a section on this part QFE, QNH, and QNE. There will be definitely one question would be coming in your theory class, because this is one of the important, because sometimes when you are flying your drone, you'll always have to see what altitude. Since we are flying a drone right now on a ground, we are not going to fly our drone on the sea water or any waterway area. So most of the time we are flying it on a elevated ground and all that. So we'll always measure with respect to that ground what. So I will tell you, okay, fly your drone up to 7 meters or 10 feet, something like that. Whatever the unit I am using, 10 feet or maybe 7 feet or 7 meters, 10 meters, whatever it is, or 3 meters, whatever way I want to communicate, or what is there you are seeing on your remote. So I'll ask what is your current altitude. So you may communicate back to me saying, okay, currently my drone is at 7 feet. So I will say, okay, you fly up to 10 feet, and from there you do pitch forward, and then you do roll right, roll left. All that things I would communicate to you, and accordingly you would fly your drone. And so that will get recorded in your flight path. So as you're flying your drone, your remote control is capturing all your movements. Later on, also you can check what is was my flight, what height my drone went, whether I brought my drone down, up, or I was deviating from my height. Then how much I went left. Left you went 3 meters. Then again you went left again 3 meters. Again you went 3 meters, and you're back to your original position or not. So all that things are recorded even in the remote control. Remote control stores all the information in its memory. So later I can download that information for my understanding purpose or learning purpose, or to see how I was flowing my drone and all the things I can do. Okay, so it is almost 4 now. So these are very small topics as we talk, and but these are interrelated to each other. Uh, uh, as per the operations and aerodynamics are concerned. So we'll start with the fixed wing operations. So we'll do this probably along with the rotorcraft operation and the hybrid operation today, and then we'll move on. So fixed wing operations and aerodynamics. So what are the fixed wing drones? Fixed wing drones are nothing but they are airplanes which generates the lift under the wing. Okay, whereas your drones, the normal drones of rotorcraft or wing, they generate because of the movement of the propellers. Where here the lift is generated under the wing due to the forward airspeed, which is produced by an external or internal combustion engine or electric motor mounted in the propeller. So you can always
सॉरी सॉरी टू डिस्टर्ब यू पण जगन तुम आप म्यूट कर सकते हो
Oh, I can hear you. I can also hear you. So you can see
सॉरी सॉरी
it is like similar to like a plane, okay, and you have a propeller in front. Okay, it is exactly like how your civilian airplane is there. Okay, it can be powered by either an internal combustion engine or by electric motor mounted with the propeller. So earlier, when there was no motors used, this kind of motor, this is BLDC motor. Okay, earlier there was no motor, so most of them these aeroplanes, the aero model aeroplanes, were initially used by the real small miniature engine like what we have in our car or a bike. There was a very small miniature engine used to come, but they were used to very expensive, and then it needs to be powered by a gasoline or something like that. So you would not usually used to get those kind of engines very easily in India. Right now they are available. You can purchase, you can build your own aircraft and fly. But after having these BLDC motors, this type of airplanes or the model airplanes have become more prominent. A lot of people are building. Even you are sitting at your home, you can within a week's time you can build your own aero model, okay, which you can catapult, or it can fly on its own runway, or you can throw using your hand, a small thing you can do it. So they are either handheld catapult or runaway takeoff, or can fly continuously over long distance as opposed to hovering. So this the only drawback of the fixed wing drones or fixed wing aircraft is basically it cannot hover at any point, because it has to continuously move in a forward speed, forward direction, forward location. It has to continuously move. That is the only disadvantage of the fixed wing drones. But these drones have a longer endurance, so that's why you will see these drones are being used, or these aircraft are being used for a very higher mission. Like you see Predator drone. Predator drone is also a powered drone. Okay, it runs on a runway, it takes off, and then it will stay in the air flying for almost 30 hours continuously till the fuel is there. 30 hours it will fly. But whereas the drones which are powered by electric, they will not fly more than 30 minutes also. The more the power it requires to stay in the air, the more battery, the more weight. So, all that will keep challenge. But here in fixed wing, only what is that? It is carrying that fuel. And at it is burning the fuel, it will become more and more lighter. But the endurance capacity of these drones is very, very high. That's why these drones, especially the Predator drone kind of drones, are used by military, because they need longer surveillance, they need longer monitoring purpose of the drones to be in the air. We do not have any drone which can fly for, let's say, more than something like that, 2 hours, 5 hours, 10 hours, 30 hours kind of thing, using electric battery, because more the endurance you require for electric drones, the bigger the battery it would become. प्रणय, तुम्हारा DJI ड्रोन का कितना है endurance?
32 minutes.
32 minutes, right? So every time you put a battery, you can fly up to 30 minutes. Again, you have to make it down. And how much time it takes that battery to recharge again?
तरी पण एक 2-3 तास जास्त जातात.
2 to 3 hours maximum you will require. It depends upon the charger and type of battery, how fast the battery is getting charged. So again, 3 hours. So normally, people who fly the drones, they will always have three set of batteries. So by the time you are using another battery, your battery will get charged. So you will set some people will take 5. So that least every cycle you will have a new battery to be used. So by the time you are on a fifth set of battery, your first battery would have been charged, like that. So that way
Yes.
you have to manage the battery power bank if you want to continuously use your drone over the longer period of time. Okay. So what are the types of fixed wing drones? So there is something called rectangular. Okay. Then there is a tapered. You can see tapered, and then there is a round or elliptical straight wing. Okay. Now, if it is rectangular or a straight, or it is little bit tapered, or it is round or elliptical straight wing. Okay. Now, if you want to see like this, the last one, okay, the rounded or elliptical straight wing, you will see in the older times, during World War One or World War Two, if you see their wings, they are more or less similar like this. Okay, they were more or less elliptical. Okay, because they give a very high efficient flying in those areas. Because the more what do you say, edge is there, it will cut the air. Whereas here, when there is a rounded corners or rounded things, your flow of the air will be very streamlined and straightforward. Okay, that's why it is said high efficient. Whereas tapered are moderately efficient. Whereas if you see the rectangular, they are very less efficient. Okay, so the more curvy you add, if you see the rocket fins also. Okay, if you have, so this is like the design where you allow the flow of the air to be in a very smoother way. If you put like for example, you are driving a car. When you are driving a car, you will understand your car is smoothly you are able to drive. But in that place, if you are driving a bus is like a square, a rectangle. So you will always see that, bus, you are not comfortable driving the bus. Okay, because it will have a lot of drag into it because of the shape of the bus. Bus is square shape. Buses are not aerodynamically designed. Okay, buses are more or less, they are just because they have more power, that's why they can afford that drag. Whereas car, you cannot have a square. Like for example, even in the car, if you are driving something like a van, small Maruti van or something like, those will also have a lot of drag. But if you see you are driving a car like Ertiga or even Innova, they are designed. They are if you see the front area, they are like aerodynamically designed cars, so that you are passing through the air very efficiently. So they are highly efficient designs. But compared to that van or bus, they are less efficient because they are rectangular in shape. Same principle applies here. Okay. Then you had a different type called swift wing. There is slightly swift, moderately swift, or highly swift. Like again here there will be low efficient, then moderate efficient, and this would be a little bit highly efficient or a highly efficient wing kind of thing. So different wings has different purposes in a fixed wing. Somewhere it might be useful for flying a longer duration, or glide will be more. Depending upon the shape of the wing, the performance of the aircraft will provide you like that. Like if you see the middle one, the moderately swift wing, these are mostly used into aircraft where they are, bomber kind of aircraft, where they have to fly at very high altitude and they have to fly very swiftly. Okay, so you will always see these moderately swift wings are used into the like B-52 bomber aircraft. You must have seen British Navy, British Air Force, which operates steel bomber, what they call it. It has a similar kind of shape over here. Then there is something called delta. Okay, delta wing is very useful in the civilian airplanes where they are using very high speed flying is required. So there is a simple triangular kind of a simple delta wing, or there could be a little bit aerodynamically. Again, delta wings have been designed. So there is a particular shape design where they optimize the shape of the wing so that they are able to achieve the high speed flying. Okay, like as you said, they are mainly more for high speed subsonics or supersonic flights. So this is where the flights are being used, or the delta shape is being used. Okay, so we have discussed about these talks. Similarly to the aircraft, the parts of the fixed wing, we can see the body or the fuselage, what we call, is there. Round fuselage is there. Then you will have propellers for forward motions. Okay, it will have its own wings. Okay, where we will have ailerons. You can see the ailerons. Then you will have horizontals. See now here the horizontal stabilizer is above the rudder. Okay, or the elevators. Okay, whereas rudder is there, the vertical thing which controls its movement, and then you will also have vertical stabilizers as a rudder, and then you have a motor, engine or a motor. It could be electrically powered or it could be combustion type motor also, and then it wheels as a landing gears and all the things. So it's exactly like your civilian airplane, but this is a smaller in size. It is only used for special missions or special activities to be performed remotely. Okay, so fixed wing RPA system, what does it has? Propulsion system, fuel system, control system, avionics, takeoff and landing system, and payload. So propulsion system is nothing but your the motor systems. The fuel will be, if there is a fuel, it could be having a gasoline tank, or if it is a battery, then there would be a battery for it. Control system is nothing but it's all the control parts, like you have stabilizers and ailerons and elevators and rudders. All those things are your control systems. Avionics is nothing but it's all electronic part where it will have all the controls, controllability of your ailerons, control of your elevators, rudders, flying and monitoring its location, its position, its altitude. All that things will be managed using the avionics or the flight controller part. Land takeoff and landing system is nothing but it just has the wheels, okay, where it will run on the runway, and then it will take off, and then when it is to land, it will just touch down and then roll on its wheel as it stop at a designated place. Okay, and then payload system. A lot of time you would see below, on the below fuselage, there would be a lot of cameras or some devices would be there which will be either taking pictures, photographs, or maybe thermal cameras would be there, or lidar would be there. A lot of things would be different payloads they would be putting it, which will be necessary data what they would like to capture. They will capture the different payload systems. Okay, so as I said, propulsion system, brushless or IC engines, and the propellers. Okay, so propellers are being powered either using by IC engines or probably by the brushless motor. So what is the advantage about the IC? IC is conventionally used system, higher endurance, as I said. Okay, whereas your motor will not give you much endurance, whereas this will give you more endurance because you will have higher capacity of fuel tank compared to the weight. Best suited for medium or large categories, and IC engines are, but they are noiser. Okay, because this engine makes a lot of noise similar to our vehicle, like it could be a bullet or any two-wheeler wherever we use IC engines. Whereas here, high power to weight ratio available in wide range, starting from miniature, small to small. You can make a small aircraft also about it and try to fly it. Okay, as just a fun. uh, Best suited for nano micro categories. So if you are using electric motor, you can build a nano or micro category aircraft. Whereas if you are using an IC engine, you can build a very big, medium or large category. That's why you will have a higher endurance here, where you will have a lower endurance. Motor, VDLDC motor is very quiet, low noise, helps in keeping low profile in stealth operation. I mean, if you are flying very close to the enemy lines, and you can use a VLDC motor aircraft and get whatever data you require to go. The propeller which are attached to either BLDC motor or IC engine, it's a lot of time. In earlier days, it was made of wooden. But right now, most of the time we have either plastic, or we also have a carbon fiber made of. So you see, made of wood, industrial or small grade plastic, or carbon fiber, they are made. So provides us thrust by rotating in size in a particular direction. So since this we are talking only about one motor, one propeller over here. If you see the propeller, it also has a similar type of a design as there was a wing. So this is like a wing only. So if you see, it will always have the. If you see closely or see closer the propeller, you will always see the propeller is similar to the wing design. It will always have a leading edge and a trailing edge over here. Okay, and based on the position of its leading edge and trailing edge, you can make out which type of this propeller is, whether this is a clockwise or anti-clockwise propeller. Can you tell me which type of this propeller is there? Can you make out? Can you guys make out? If you want, I will just make it a little bit bigger. Can you make out what type of this, whether it is a clockwise or anti-clockwise? Of course, on the propeller, it is written, either it is written CW or it is written CCW. CW means clockwise. When it is CCW means counterclockwise. Of course, on the propeller, it is written. You have to see it very closely. Okay, but just by looking at the propeller, you should able to tell whether this proper propeller is CW or CCW. Can you identify? Can you take a guess?
Clockwise.
Okay, Pranay, you.
Counterclockwise.
Okay. Can you tell me why? Why saying clockwise or counterclockwise is very simple. But why do you think that?
Because if I see from here, if I fix in the front, assume like from a front, it will turn like this because this place looks thick.
But as you are showing me, Jagan, what you are saying, and what you are demonstrating is contradicting.
Okay.
You got it? What I'm trying to say. You
Yes,
said
yes.
clockwise, but you are showing me the direction
Counterclockwise.
anti-clockwise.
मी म्हणालो क्लॉकवाईज
Counter.
तो ते काउंटर क्लॉकवाईज म्हणे उलटा म्हणाले.
My bad. I may be wrong. So whatever. See, this is counterclockwise. Because if you see, the trailing edge is this. Trailing edge is this. Yeah. This is the this is the leading edge. is the leading edge, whereas this side, this curved path is the trailing edge. So actually, the drone, the propeller will move like this, anti-clockwise or counterclockwise.
अच्छा, मग मी चुकीचं बोललो, आय एम सॉरी.
It will move like this. Okay, clockwise means it will be movement, like how your clock moves. Okay, this is anti-clockwise or CCW. This propeller is CCW. I will show you when we see the entire drone, na, six hexacopter or octocopter, we'll see. I'll show you tomorrow. I don't have right now the drone over here. Okay. Then we'll move. We'll see when we see compare both the type of propeller. It's more comfortable.
माझ्याकडे आहे, मी दाखवू शकतो.
You can show if you have.
I'm back.
So this is what. See the head.
हे असं फिरणार.
Can you just hold it little bit back? Out of. Just hold it in the center. Just hold the center part. जे आपण मोटरला लावतो ना, सेंटर पार्ट मध्ये पकडून. करेक्ट. So can you see?
दिसतंय का?
I can. Yeah, we can see. So this is clockwise. This is clockwise. Correct? This is clockwise. This is clockwise. Clockwise. Correct. This is clockwise. Clockwise movement.
आणि हे अँटी क्लॉक.
But not this propeller. You have to go for a different propeller. Different propeller. दुसरा प्रॉपलर पाहिजे. दुसरा नाही, तो नाही, म्हणजे त्या सेटचा नाही, दुसऱ्या सेटचा.
दुसऱ्या सेटचा. ओके.
अदर सेट.
एकच मिनिट आलो.
Two types of propellers, clockwise and anti-clock or CCW or counter-clockwise propellers. So a lot of people when they are flying the drones, they do not understand. I mean, people when they fly the drone or they see the drone, they feel that all propellers are same, okay? Or they are moving in the same direction. Nobody also knows that the propellers. If you have two propellers in front, both are moving in different directions. Back also they are moving in different directions. Okay, so the combination of their movements makes the drone fly out. I mean, that's a really interesting to understand that.
यातलं काय आहे का म्हणजे?
Now if you see, उल्टा पकड़ो, उल्टा. up. ये क्या है? ये बेस है ना, नीचे का है ना?
हाँ, बेस है.
उल्टा पकड़ो, उल्टा. up arrow. That way. डाउन दिखाओ, डाउन. नहीं. बैटरी तुम्हारे साइड करो, बैटरी का साइड तुम्हारे साइड करो. बैटरी.
ओके.
Hold it vertically. नहीं, उल्टा. Battery should be at your side.
Like this?
Correct.
Okay.
So if you see in your your right hand, right hand is your clockwise.
Okay,
जो टच कर रहे हो, और आप लेफ्ट साइड पे जो आपका प्रोपेलर है, which you are not holding it, लेफ्ट साइड का. This one. This is anti-clockwise.
Okay.
But again, if you see the propeller which is below now, which you are holding, that is clockwise.
This one.
नीचे का propeller. Ah, that is clockwise.
म्हणजे आता मला कळलं की हे क्लॉकवाईज आहे तर हे अँटी क्लॉकवाईज.
अँटी क्लॉकवाईज आहे, तो उसका ऑपोजिट क्लॉकवाईज.
क्लॉकवाईज तर अँटी क्लॉकवाईज.
Correct.
So diagonally it
Okay.
will work.
Diagonally. Correct.
हा.
Let's say if there, like here there is a 4, so it is very easy to understand. Let's say there are 6. So one will be clockwise, anti-clockwise, second clockwise, anti-clockwise, again clockwise, anti-clockwise.
आणि ह्यांच्यावरती मार्किंग पण आहेत की.
Marking, yes.
Okay, okay, okay. Thank you.
So you see opposite, they are clockwise. So again, I'll tell you another logic. When you are putting a drone, there is a front part of the drone, there is a back part of the drone. Like आपके back part मतलब पीछे से जहाँ से आप battery insert करते हो, that is your back part. Your front part is where you have the camera, right? That is your front side of your drone. Now when you see the drone in that orientation, the front side is in front, okay, back side is facing towards you where you put the battery. If you see the front side, your left side and the right side drones, they will be converging like this. So this side, my left hand side, it will be a clockwise propeller, whereas on my right side it will be anti-clock. So drones propellers are moving inward. Okay, but where you see in the backside drone, because since they are opposite, your propellers are outward. When you actually see, you will make out this difference, and that's how you will understand how your drone is made or built, or how you understand whether it is set properly or not. By looking at the drone itself, you will be able to understand, okay, this is how the drone is, this is how it is going to fly, whether it is set properly. Sometimes when you change the propeller, a lot of time engineers make mistakes. They connect wrong propellers. You should know. Even on the motor, the OEMs make the marking. On this motor, you have to put clockwise propeller. On this particular motor, you have to put counterclockwise. Sometimes they put reverse. Sometimes engineers make mistakes because they have not been taught. For them, some people just think that propeller तो एक जैसे ही दिखता है. मतलब until unless you don't observe and understand this concept, you will feel that all propellers are same. When the aircraft was flying, forget about the drones. In older times, when the aircraft was flying, both side propellers were moving in. Even the first aircraft which was flown by Wright brothers, both both propellers, what they were designed, they were moving in both different directions. They were moving inward. Imagine if they would have been flown in, what would have happened? Their aircraft, when they were flown, it would have been gone like this. Just to make it stable, that's the very interesting and engineering thing what Wright brothers have done it at that point in time. And they, if you see a video also on YouTube or anywhere, wherever, the one propeller which was moving, it was connected to one same engine. So there was only one engine. Okay, so they connected a what we call, I forgot, the chain. Like how you have a chain in a bullet or a bike, they have a chain over here. So which will move the one propeller. The other propeller, they have reversed the chain. They have reversed like 8. So it was moving like opposite direction. Same direction it was, but since it was supposed to go like this, they have just reversed it. Very interesting design. But that solved the problem. If they would have connected the belt in the same direction, what would happen? It would have, both the propellers would be flown in the same direction, so it will give the thrust and the plane would be turned upside down. That would be a disaster or failure. Probably they might have encountered that failure when they were not doing demonstration. And that's how they would have solved that problem that point in time when they actually were supposed to make it. Okay. So that's why you always see one propeller clockwise, other propeller anti-clockwise. Same thing if you see, forget about this example. If you see helicopter has only one blade. If one blade aircraft can fly, but what happens? It will fly, it will go up, but by the time the propellers are moving, the body will move in opposite direction. Just to counterclockwise, there is a small fan at the back. So it will always put it at the same position and it will go further. Okay, when a helicopter is flying, they change the pitch of the blades. If you have noticed very carefully the aircraft, they change the pitch of the blade, which makes it go forward and backward. So that there they are changing the angle of the blades. So your blades, see that's why that topic what we learned about principles of flight, the shape of the wing or the shape of the propeller, they are all same. That's why that leading edge, trailing edge, the front part is thick. If you see the propeller, Pranay, if you see the propeller, the leading edge is thicker compared to the trailing edge. Trailing edge is sharper.
Yes, yes.
Right? So let's. It's very interesting as you talk about the topic. And okay, so I'm just sharing back my screen. Okay. So again, fuel system, as we see these propulsion systems, be it BLDC motor or IC engine, it needs to be powered up. So for motors, we'll use lithium-based batteries, LiPo or Leo, widely used batteries, custom built, different shapes and sizes, capable of higher endurance flights. Energy density is far less than the IC engines. But if you see the liquid fuel, okay, it is a tank. Okay, it either, as I said, gasoline or diesel is normally used for flying this. They have a better thrust to the weight ratio compared to the lithium batteries, because lithium will not give you that much thrust what these engines gives, because this gives very powerful pickup. Their rotation is very high compared to the battery what powers the motor. Okay, so there are alternate things are also coming up recently. We have seen a lot of things moving with the hydrogen. So hydrogen powered aircrafts are also coming into picture, or even solar powered are also coming up in the picture. But both has its own limitations as well as positive things about it. So over the period of time, we'll know which one is better, how long we can fly. Then contacts, basic controls, as we talked about. You see there are two controls on the remote control. Okay, so you have a left side and you have a right side. Okay, you have a right side and you have a left side. So on your right side control, if you move towards the right, that is roll. Okay, and then you have a center part again, that is a pitch, back and forward. Then on your left side, if you move further, you further, that will be a throttle. Throttle means height, up and down. Okay. Whereas if you move your left side, it is yaw. Now, when you take the remote control in your hand, okay, depending upon, like, we in our region, we use the remote control in something called as mode 2. Mode 2. Okay. So in mode 2, your right side control is roll, and then you have pitch. Okay. So we call it as RPTY. RPTY. Okay. RPTY. Roll, pitch, throttle, yaw. So your right hand you have roll, you have pitch. On your left hand you have a throttle and yaw. So RPTY. Understand this? RPTY. Okay. This is mode 2. Whereas if you go to US and you fly the drone, it is opposite. Okay, so your roll and pitch is on your right side, whereas sorry, on your left side, and your throttle and yaw is on your right side, opposite one. So that is actually a mode 1. Okay, so sometimes you need to change your settings from mode 1 to mode 2. If you have brought any remote control from US, you have to change. Like even in European countries, they use mode 2 only. In Asia, also most of the places they use mode 2 only. But in I think in USA, Canada location, they use mode 1. There is nothing difference. It depends upon, mostly it was because initially some people were left-handed and all the things. So that way people had made it. So now it is called as mode 1, mode 1 and mode 2. We Indians or any place, most of them, I mean 99% your remote would be in mode 2. If it is brought from US or Canada or any places where they are using mode 1, it will be mode. So you have to change the setting into the remote control as mode 2 if you are flying in India. Or if you are trained as a mode 2. नहीं तो आपका throttle के जगह पे pitch हो जाएगा और roll के जगह पे yaw हो जाएगा.
What is mode 2? Mode 2 is left is RP, right is
So roll, pitch, throttle, yaw. So roll and pitch is on your right side, throttle and yaw is on your left side.
I mean, having roll and pitch in the right side and throttle and yaw left
On the
side,
left side. Yeah.
is mode
2.
2.
Mode 2. If you have throttle and yaw on your left side, sorry, on the right side and roll and pitch on the left side, it will be mode 1. Vice versa. Okay. Here you can see that another. Okay. This is a control system. So you see, now you will see much better. So your right side is roll and pitch, RPTY. Right? Your left side control is throttle and yaw. So you call it as channel 1, channel 2, channel 3, channel 4. That's how your channels are been defined. This is mode 2. See your written mode 2, both of them. Okay, and then you will see a lot of switches are there. So those are different channels. Okay, so when we do simulators, we will see these settings also. So mission planning, there is a software called Mission Planner, which is nothing but a ground control station for plane, copter, or rover. It is compatible with Windows as of now. Mission Planner used for configuration utility as a dynamic control supplement for autonomous vehicle. Like if you don't want to fly a drone, especially in agriculture, if you're flying for a purpose of agriculture, I do not want to, fly the drone. I want drone to do all the tasks for me because let's assume that you have to fly a drone for 1 acre to 10 acres. You will be fatigued. You will be stressed out, and then you will not able to see. So why you want to take that long stress? So what you will do is you will configure the mission planner in a such a way, the software, and it will give you the directions. You will set everything, how much distance between the two paths, how much distance from the boundary, if there is obstacles, if there is a tree, if there is a well, if there is a power line tower, anything is there. Everything you will define into that plan, and you will give the command to the drone. Drone will do rest of the thing, and you will just keep on monitoring the remote control. You don't need to go give throttle. You don't need to give pitch. You don't need to do yaw. You don't need to do roll. Anything like that. You just keep monitoring. See, for example, the drone battery capacity may be let's say my agriculture drone endurance is 20 minutes. Okay, and I am flying drone on a field of let's say 2 acres. Okay, for 1 acre or let's say 5 acres. Okay, and 1 acre I am able to do it in 10 minutes. So my battery is capacity is 20 minutes, but my tank capacity is only for 10 minutes. So what will happen? I will set the settings into the drone in such a way that it will fly the drone, it will go, it will spray, and as it reaches 80% or maybe 90% or maybe 100% of my tank is empty, it will return back to the launch point. I will refill again the tank since my battery is only consumed 50%. So I will again refill the tank and I will say resume. Automatically again drone will take off and it will go to the point where it stopped, the spraying. From there it will resume again. Again it will flow for 10 minutes, and then now this point in time my tank would be also empty. My battery would also be reaching to the end points. I may set the battery to 80% of throttle, so 80% of power. So I know that I should have some reserve battery so that it has to fly back to the flying launch location. So at that point in time, my tank would be also empty and my battery would also reach 80%. So that point in time, it will again go as a RTL and it will come back to my landing point. It will land over there. I will change the batteries. I will put again the refill the tank. Again, my cycle will continue. See, there are so much work you need to do during such kind of activities. You can't do this activity as well as you fly the drone. So ease out your mind, ease of or simplicity of your activities. You will always use some software like Mission Planner software is there. Okay, it is a free software available, but most of these drones which are being sold by OEMs, they customize this Mission Planner software as their own software. So there is a complete code available for this software. You can take that code, you can customize, you can improvise on it, you can add features to that, all that things you can do it into that, and you can sell it as your own software also. Okay, that's how when we are flying the agribot or any other drone, they will have their own GCS software. Okay, that's what ground control station, what we call. So GCS. So like
Is it online or offline?
online. You can download this mission plan.
No. I mean, how it works real time? So
You have a laptop.
okay.
You
I mean,
have a laptop.
do I need an internet connectivity while
No,
using?
not internet. It is. I mean, internet is required for your laptop to work, but that signal is through the your remote control. So your remote control will be connected to your laptop through a cable.
Okay. At the moment of doing this task, I mean, example, we'll take agriculture. I'm doing some pesticiding. Uh, in that particular time, maybe I could be in some remote area, right? So in that case, I won't be having any internet.
You
So
don't
if
require.
I
When you are flying a drone, you are not using internet, right? Anyway, when you are using a remote control, you are not using internet. You are flying through remote. So what happens? Your remote control is taken by the software.
okay.
Okay, so instead of you giving the signal, you are setting the plan into the software, and that plan is being executed on the remote control, and remote control gives the signal to the. So there is a cable connected between the uh, remote control and the laptop.
Okay.
There has to be some connectivity has to be established between remote control and the laptop or a desktop, whatever you are using for the purpose of. Or you don't need to do this also on your laptop also. Right now, whatever the remote controls they come with this software built in into that this thing also. So on the remote control itself, all the setting what we are supposed to do it here. That's what I'm saying. They have customized this software in such a way that instead of having a separate control, they have put a small tablet. Like if you see the controllers, what we are using, it is like itself is like a mini tablet kind of thing. So you can easily touchscreen tablet is there. You can do all the settings into that remote controller and you do it. So you don't require to have a separate laptop also. So using that control, you just hold control in your hand or you just put it on a tripod, sit and watch. That's it. It will do all its activity on its.
सर मी काय म्हणतोय, एरिया मॅपिंग त्याच ड्रोनने होते का, ज्याने आपण ऍग्रिकल्चरचं काम करणार आहोत, म्हणजे फवारणी वगैरे
कर सकते हैं, प्रोवाइडेड आपको उस पे पर वो पेलोड लगाना पड़ेगा ना. फॉर एग्जाम्पल अभी एग्रीकल्चर स्प्रेइंग जो कर रहा हूँ उसमें क्या रहेगा, टैंक रहेगा. बट एरिया मैपिंग करना है मेरे को, तो आई नीड अ हाई एंड रेजोल्यूशन कैमरा, राइट. आरजीबी चाहिए मुझे. तो वो आरजीबी उस पे लगा सकते हैं क्या? नहीं लगा सकते ना, बिकॉज दैट इज नॉट द ड्रोन विच इज सर्टिफाइड फॉर मैपिंग. दैट ड्रोन इज ओनली सर्टिफाइड फॉर स्प्रेइंग एंड सीडिंग. यू कैन सी एंड ऑफ द डे ड्रोन तो ड्रोन ही है, राइट. ड्रोन को सी इट विल फ्लाई वेर एवर यू हैव डिफाइंड. सो अभी आप स्क्रीन पे जो देख रहे हो, if you want to map that particular land, it will map it. See, drone doesn't understand what activity you are doing. It will just follow the commands, right? So अगर उस पे आपने टैंक निकाला, फॉर एग्जाम्पल मैंने मेरा एग्रीकल्चर ड्रोन का टैंक निकाला एंड वहां पे मैंने एक गिम्बल लगा के आई पुट अ कैमरा बिलो इट. Okay, and I set my remote control in such a way that I am able to monitor or I will able to manage the gimbal and the camera positions. मेरा ड्रोन में फ्लाई कर रहा है, मैं ड्रोन को सेट किया, उड़ाया, the camera will take the pictures or take the complete data what I require to capture. It will function.
Okay.
Got it. So drones now have many functions, okay, ranging from monitoring climate change to carrying out search operations after natural disasters, photography, filming, and delivering goods. But their most well-known and controversial use is by military for reconnaissance, surveillance, and targeted attacks. तो हमने ये देखा है drones used for different purpose. I mean, this is just a some of the purposes what it is shown, like monitoring the climate change, carrying out search operations after natural disasters, photography, filming तो हम लोग करते ही है, especially even delivering the goods. Like in US, Amazon uses lot of drones for delivering the goods. Okay, but most important drones का uses तो maximum जो usage हो रहा है drones as of now is more or less for the military purposes or reconnaissance, surveillance and even the target attacks. आपने देखा रहेगा यूक्रेन रशिया के वॉर में तो entire warfare is got changed because of the Russia Ukraine war. Like if you know the history, you know World War One was more or less was rifle and the trenches. Okay, World War Two was more or less war between the tanks and the aircraft. World War Three happens, it will be not the people who will be fighting. It will be that fight of a technology. If you see, because of the Russian Ukraine-Russian war, your tank is of no use in the war nowadays because your tank is such a $1 million cost of a tank, and that tank has been destroyed by 20,000 wala drone. So the value of the tank is gone zero now. There is no use.
Yes.
Okay, so the future war will be more of a technology strategy, more of from a I would say this kind of devices. Drone warfare हो सकता है, robotics war हो सकता है, automatic आपका guns लगाया रहेगा. A lot of things would be there. I mean, even tank, they will not be much bigger tanks. There will be smaller tanks now, which will which will be unmanned tanks. People will call them. अगर loss भी होता है तो there won't be a human loss. So the smaller tanks on its own, it will go to the enemy territory and it will fire the shells, something like that. Okay, you are sitting remotely and you are controlling your tanks. So it is more of a strategic and technology warfare will happen if there is a World War III kind of thing. Okay. So as we see, aircraft takeoff and landing recovery is handheld, catapult, or runway takeoff, or sometimes recovery is also through a parachute, or sometimes even in the net recovery also. There. So that's what different way the aircraft, fixed wing aircraft are being used. तो एप्लीकेशन एज वी सेड एग्रीकल्चर में भी मैपिंग के लिए यूज होता है, सर्वेलेंस के लिए यूज होता है, वाइल्ड लाइफ प्रोटेक्शन के लिए यूज होता है. इफ यू वांट टू सर्वे अ वेरी लार्ज एरिया, so there mostly you will use the aircraft or fixed wing drones. Like for example, you want to survey Amazon, Brazil में, Amazon, Argentina में, you want to Amazon area or Amazon forest or something like that, or you want to survey the African continent, which is very big in size, and you want to monitor the wildlife protection and all. So that is the area where I will use the fixed wing. But if I want to fly a drone or for a surveillance or something for a smaller area, like 1 acre, 2 acre, 10 acres kind of thing, so I will use rotorcraft. But if I want to see a bigger portion of the land, like for monitoring of the crop over a bigger area, like I want to survey the complete Gujarat, how the crop is evolved over the period of time. So I may use a fixed wing aircraft to give a survey of a bigger land or area. Okay, so comparison of fixed wing with the multi-rotor. Fixed wing, as I said, it cannot hover, so unable to maintain the fixed position, cannot fly horizontally. Sorry, can only fly horizontally. It cannot, change. I mean, in multi-rotor, you can hover, you can move left, right, all that thing. Require hand or mechanical launch again. But it has advantage longer average flight times, carry heavier payloads, great stability in the wind, and generally high flight speeds. Whereas multi-rotor, they are easy to control and maneuver, then have ability. The most important is the ability to hover, take off and landing vertically. So, but the challenge is limited flying time because of the battery, small payload capabilities, and then less stable in the wind because there is no surface which can control the air. All these things, okay, and lower flight speed because this also doesn't fly very fast compared to the fixed wing. Okay, so these are some of the advantages and disadvantages of fixed wing over the multi-rotor. Okay, do you have any questions with respect to fixed wing. We can take that, or we can go to our rotorcraft. Or you want to take break because already 4:47 हो गए हैं. So we'll take a 10 minutes break if you want. Because then we have two topics.
Couldn't hear you.
You want to take 10 minutes break?
So what's the time now? Okay, 4:47.
4:47. 4:50.
Yeah, fine, yeah.
So we'll come back at 5 o'clock.
5 o'clock, yeah.
And then we'll take these two topics. Right?
Sure.
More or more similar only. So hybrid is not big. It's hardly 10 minutes. So this is smaller. Important is this because this is the topic which is related to our license. So this is more important to discuss. So we can spend time on it. Okay?
So
Yeah.
this fixed motor, I mean this fixed what is it?
Fixed wing. Fixed wing.
Yeah. Fixed wing UAS can also be under 500 kgs, right?
I mean, fixed wing can be 250 grams also. Fixed wing can be also within 2 kg. Fixed wing can be also between 2 kg to 25 kg. That will fixed wing small category, small class. Fixed wing large class. Fixed wing medium class. So whatever those 5 classes are there are applicable to fixed.
Okay.
That's why it is called unmanned aircraft. If it is fixed wing above 500 kg, it will become a fixed wing unmanned, but it will not fall under, it will not be under unmanned. It will be large class, or it will be called as aircraft also. Like your Predator drones, they are very big capacity. They are very big. But they are not being afforded by any local person, normal people or anything. They will be more or less being used by defense.
Okay.
Whereas small fixed wing, we can build our own also for flying, for recreational or enjoying. We can. We'll connect in 10 minutes back.
Sure.